these are the 3 rules that you would have seen in the previous 2 videos that you were supposed to watch. So if you have any variables in the denominator, remember the denominator never can equal 0. If we see a radical, we're going to look at the nth root. If the nth root is even, then we have a restriction on the inside. The inside has to be greater than or equal to 0, unless that radical is in the denominator. We know that we can never have the denominator equal to 0. So in that case, we have to take away the equal sign at the bottom, and this value just has to simply be greater than 0 or positive. Okay, let's look at example 1 and example 2. So in example 1, when I'm looking, I'm focused on, is there any restrictions? So I see a variable in the denominator. So the first thing I do, as I go x minus 7, it cannot equal 0. I add 7 to the opposite side. X cannot equal 7. We were instructed to make a number line that is able to showcase what the domain is, or the input values we're allowed to plug into the function. Here is 7. It cannot be 7, but it can be anything else. So how do I represent that? An interval notation. Comes from the far left all the way up to 7. We can't include it. And then anything to the right of 7 we can include. When I look at number 2, I don't have a variable in the denominator, so I don't need to worry about it. I don't have a radical, I don't need to worry about it. That means there's no restrictions what I can plug in. Let's look at number 3. So I'm going to bump this up. Let's look at number 3. In fact, I'm going to take and put our rules down below. So here is number 3. Okay, number 3, if we look at the rules, we don't have a denominator that has the variables. We don't even have a radical. So there is no restrictions, negative infinity to positive. Now here's where it changes and it gets confusing. Let's look at example number 4. Number 4 looks very similar to number 3, but what I've done is I've thrown in a radical. If we have a radical, we're going to look, what is the nth root? If we don't see a number here, we assume it's a 2. If we don't see a number there, we assume it's a 2. Don't come to class if you can have a video on. Put your phone away. This portion inside, notice that the radical with the nth root that's even is not in the denominator, so this is the rule I'm going to follow. I'm going to follow the rule that this inside portion has to be greater than or equal to 0. And now this goes back to what we learned in Unit 2. So when we have a problem like this, remember, if it just a little bit of insight, remember how we would find the hashtags, and then we decide is it yes, no, yes, or vice versa, no, yes, no for the shading. The shading represents the points we're allowed to plug in. So because I have an inequality symbol, I'm going to start by finding the hashtags. X squared minus 9x plus 20 equals 0. That's going to allow me to find the hashtags. What multiplies to equal positive 20 and combines to equal negative 9? That'd be negative 5 and negative 4. Okay, x minus 5, x minus 4. I'm going to take each one of those factors, I'm going to set it equal to 0 and solve. X equals 5 is one, x equals 4 is the other. So I put the smaller of the two numbers to the left, the larger of the two numbers to the right. And then I have to decide at those points, go back to what the inequality symbol was. It was greater than or equal to. That means at these points I have closed dots. And now I decide where should I shade. So I always think that as long as your hashtag is not 0, I think 0 is the easiest number to plug in. So I know 0 is way over here. I'm going to test 0. And as a reminder, it's going to be like shade, no shade, shade. Or vice versa, no shade, shade, and just opposite of one another since we don't have duplicate answers. Okay, here we go. I'm going to test 0. So this is what I go back to test 0 with. Now, I would use mental math, but if you need to use a calculator, it's going to look like this. If you need to use a calculator, 0 squared minus 9 times 0 plus 20. This is the value I have on the left-hand side. I get a value of 20. You can definitely do mental math with that. Is this a true statement? Is 0 greater than or equal to, is 20 greater than or equal to 0? Yes, I tested 0 is to the left of 4. That means this is a yes, this is a no, and this is a yes. So I shade this way and I shade this way. Now I'm going to prove to you how this does work. I'm going to come up here, and you don't have to do this, but I just want to show you. I have the square root of x squared minus 9x plus 20. I graph it, and we can see that it goes all the way to a value of 4 up to the left and value of 5 off to the right. Here we go, looking right now at number 5. So the first thing I do is I look at my rules. Do I have variables in the denominator? No, so I don't worry about rule 1. Do I have a radical? Yes. It's not in the denominator. It's not in the denominator. It's simply a radical. Then I focus on the nth root. If there's a value there, I have to see is it even or odd. If it's odd, there is no restrictions. So negative infinity to positive infinity. Let's look right now at number 6. Number 6 is a little bit different than yesterday. Let's look at number 6.
You got it.
Yes.
You got a pencil?
Yes, I do. Right over there, there's a box. Do you see them? It was carried in. Let me find it. Okay, let's look at right now number 6. So number 6 has a couple things that we need to be aware of. Number 6, the first thing is, let's do the easier of the two things. I see a variable in the denominator. So I need to focus on, first of all, making sure that the denominator does not equal 0. If it would equal 0, it would be undefined. So I'm going to go off to the side and write x plus 2 cannot equal 0. And then just quickly solving, I know that at no time can x equal negative 2. If that occurs, I have 0 on the bottom. It's undefined. Can't happen. Remember, determining the domain means what am I able to plug in, and I get a corresponding output value or y value. Next, I see a radical in the numerator. So I'm looking here, and I'm going to focus on the nth root. When you don't see a number here, what is a hidden number? It's 2. So I know it has to follow this rule. What's inside has to be greater than or equal to 0. So I'm going to take this portion, and just like example number 4, I'm going to set it greater than or equal to 0. And now I'm going to start by doing the hashtags. So just like in unit 4, we were going to write x squared minus x minus 24 or 42 equals 0. I come off to the side. What multiplies to equal negative 42 and combines to equal negative 1, negative 7, positive 6. And this allows me to find those hashtags. One hashtag will be 7. The other hashtag will be negative 6. So I'm going to start on my number line, and I'm going to try to choose 2 different colors so this stands out for us. 2 different colors. Give me 1 second to find another colored pen. There we go. Okay, so let's identify the 2 hashtags. We have a hashtag at negative 6 way down here. We have one at 7 right here, and 2 is going to be right about here. Now, I know that we can never select 2 or the function would be undefined. So I'm going to ignore this right now and decide for these 2 hash marks, when it comes to shading, is it going to be yes, no, yes, or vice versa, no, yes, no. What is the easiest number to choose? I think it's 0. As long as the 2 hashtags are not 0, we can choose 0. So 0 is like right here. I'm going to test 0 right now with this inequality. And yes, I could plug it in the calculator, but I think it's easier just to do mental math. 0 minus 0 is 0. 0 minus 42 is negative 42. Is this a true statement? I tested 0. Is that a true statement? It's not true. That means this area right here is a no, and the yes is going to be in this portion and then this portion. Now we still need to decide at negative 6 and 7, is it a closed dot or open circle? Please talk to your group. Is it a closed dot or open circle based on this? It is a closed dot. So I don't need to actually go ahead and identify that 2 cannot be selected, because we can see in both situations this area cannot be selected as part of the domain. The domain is negative infinity up to negative 6, and from positive 7 all the way to infinity. Okay, so this bottom part, I'm following this rule because this is even. So this portion has to be greater than 0. Now I'm deciding, is it yes, no, yes, or vice versa, no, yes, no. We can't choose 0.
Yeah. But it's because I didn't know that.
when it's a hash mark, you cannot choose it. So let's choose another number. Let's choose like 1. So I'm going to choose 1 up here. 1 squared is 1. 9 times 1 is 9. Is negative 8 greater than 0? No. So this is a no. This is a yes. This is a yes. So our last one for this particular recap of learning. I see two things. I see that we have a variable in the denominator. I recognize in this case that x cannot equal negative 6. If you're working in groups, just make sure you're whispering right now so people can hear if they need to. X cannot equal negative 6. I recognize that I have a radical. It has an even nth root, and it's in the numerator. That means this portion has to be greater than or equal to 0. X squared minus 3x minus 28 has to be greater than or equal to 0. I'm going to start by finding the hash marks. So I set that portion equal to 0, and I factor. When I factor, I'm looking for what multiplies to give me negative 28 and combines to give me negative 3. And I get hash marks of 7 and of negative 4. I always think it's easiest for students to first mark down the negative 4 and the 7. Notice, by the way, notice that it's equal to. So I'm going to have closed dots here and here. And now I decide, do I shade to the left, to the right, or do I shade in the middle instead? So I'm going to choose 0. I'm going to plug 0 back into this inequality statement. 0 squared is 0. Negative 3 times 0 is 0. So I have 0 minus 28. Negative 28 is greater than or equal to 0. Is this a true statement? The answer is no. That means this whole region is no. So where would I shade? I would shade, if I had a pencil here, I would shade to the right of 7 and to the left of negative 4. But now I need to also compromise and include this other statement. X cannot equal negative 6. So I have to also show that we cannot select negative 6 or we would have an undefined statement. So this is what I have. I saw a few students with that. How do I actually identify this in interval notation? It comes from the far left all the way up to negative 6. We do not include negative 6. Then it goes from negative 6 to negative 4. We include negative 4. Then it starts back up at 7. We include it all the way to the right.